Hi, this is Mrs. Kidman, and in this video, we are going to be discussing rational functions. So what does it mean for something to be a rational function? Well, a rational function is something that has an x value in the denominator of a fraction. So a rational number, remember, is one that can be written as a fraction. So it might be like 1/2. So all of these functions are going to be rational, meaning they're in the form of a fraction, but our x value is going to be on the bottom. So this is the parent function. Remember, our parent function is our most basic function, and they have some specific characteristics. So when it comes to rational functions, they have something called a vertical asymptote. I'm going to abbreviate it with an ASY, and they have something called a horizontal asymptote. And you may be wondering to yourself, what is an asymptote? Well, an asymptote is a quote unquote line, so it's not actually there, but it's this hypothetical line that the function never touches. So for example, in this one, we've got a vertical asymptote right here at x equals 0. And we also have a vertical asymptote or a horizontal asymptote at the line y equals 0. Now, why do these asymptotes exist? Well, what they really mean is that it's impossible for me to get a value here, or to put this number in and get something out, or vice versa, to put any number in and get it out. Well, let's really think about this here. If I put 0 in, I would get 1 divided by 0. Can we do anything divided by 0? No, that's undefined. We don't know how to solve that. And so we can't have any values there at what would make our denominator equal to 0. And that's really key with these rational functions. Our denominators cannot equal 0. So we're gonna have this asymptote, or this line that the function never touches, wherever the function is divided by 0, whatever x value that'll do. Similarly, we have a horizontal asymptote at y equals 0. And we have this asymptote there because what happens is it's impossible for me to put any number in for x and to get it to equal 0, right? Because in order to get the number 0 out of a fraction, we have to have a 0 on top. Now, because we don't have any zeros on top, it's impossible for us to get that. So this is that most basic parent function. It looks like this. Now let's take a look at a couple of other functions and see how they compare. So let's compare the graph of g of x equals 4 over x with f of x equals 1 over x. Now g of x is the red one and f of x is the blue one. Now you can see what are things that are the same. Well, if I went in to draw that vertical asymptote, we can see that they actually have the same vertical asymptote. They have that vertical asymptote at x equals 0. They also have the same horizontal asymptote right here at y equals 0. So that horizontal asymptote is at y equals 0. But what is different about them? So they have that same sort of shape. All of these rational functions have this kind of like curved shape. It's called a hyperbolic shape. But what's different about them? Well, you can notice that as we go from that 1 to that 4, it's like the function stretches, right? So instead of being right here at 1, 1, it's now got a point here at 2, 2. And so it's like it's stretched itself out. It's pulled itself a little bit away from that x and y axis. And so it's not quite as sharp of a curve. Interesting, right? So let's talk about what happens when we look at this graph then. The graph of g of x, which is -6 divided by x, versus f of x, which is 1 over x. So let's go ahead and draw an x and y axis here and see what happens. So our original one here has a point right here at 1, 1. We can kind of look here at our function. It kind of starts there at that 1, 1 point and it just goes. So it looks kind of like this, right? So here's one direction, here's the other direction. And that's our horizontal, that's our graph of f of x. So this one is in black. In green, we're gonna graph this other one, this -6 over x. So how can we decide what to put in? Well, I can't put 0 in. What happens if I put a -1 in? Well, I'm actually gonna get the number 6. 1, 2, 3, 4, 5, 6. What happens if I put a -2 in? Well, we end up getting the number 3. If I put a -3 in, I get 2. If I put a -6 in, I get 1, 2, 3, 4, or 1, 2, 3, 4, 5, 6. We get 1, and we see that our curve looks like this. So it's a little bit less steep and sharp. Same thing happens over here. As we reflect across this axis, we can see that as I put in a +1, we end up getting a -6 right here. As we put in a +2, we get a -3. A +3 is at a -2. Then we end up over here, next thing we know, at 6, and we've got our curve that looks like this. So notice how they're a little bit different in what they look like. What's the same? Well, guess what? They both still have that asymptote, that vertical asymptote at x equals 0. They both have the horizontal asymptote at y equals 0. But what's different about them? Well, that green one was reflected across the x-axis, right? So reflected across, not the x-axis, kind of the x-axis. It looks like it was reflected across both axes. So it was reflected. It was also going through that stretch component that we saw in the previous lesson. So what I want to ask myself is, how do the numbers in a rational function affect it? Well, let's take a look here. A rational function is actually transformed based on the elements that are put in there. And so when we have a rational function of this form, y equals a divided by x minus h plus k on the outside, what it does is it actually affects our function directly. So how does it affect it? Well, let's start with the letter a here. We've got two options. If it's positive, we're going to get a graph that looks something like this. If it's negative, it's going to actually reflect it, and it's going to be in those other quadrants. So positive is going to be in quadrant 1 and quadrant 3. Negative is going to be in quadrant 2 and quadrant 4. Okay, so you see how they're in opposite quadrants there. Not fully, but that's kind of the idea. How else does A affect it? Well, we saw before that the bigger the A got, the more it affected it. So if A is greater than 1, not including its positive or negative, what it does is it's going to stretch, meaning that it actually gets wider, it's less thin. If A is between 0 and 1, then it's going to compress. And what that looks like is it actually makes our function look like it gets even steeper than what we see in this function, which is kind of hard to believe. Now that's A, just A does all of that. What do these other elements do then? Well, what does H do? Well, think about anything else. H is always affecting the way that it moves. So if we have something like x plus h, what that's going to do is it's going to move it to the left h units. So it's going to go to the left h times. If we have something like x minus h, it's going to go to the right. Now I know we think it should go to the other way, but this is actually the way it is every time we have something with that h, and you'll learn that. So that's how it shifts it that way. Then we have our element k here. Now what k does is if k is positive, so if we have a plus k, then it's going to shift our graph up k units. If we have a negative k or something minus k, then it's going to shift it down k units. Okay, so just like h and k typically do, h shifts it left and right, k shifts it up and down, and that a changes the way that it looks. The last element that's really cool about this is how our asymptotes relate. So you can see right here that our y asymptote is going to be wherever k is. So if we have a plus 2, our y asymptote is going to be at 2. If we have a minus 7, our y asymptote is going to be at negative 7. Similarly, our vertical, so that's our horizontal asymptote. Our vertical asymptote, similarly, is actually going to be related to wherever that h is. So that is going to be x equals h. So if it's a plus 3, so if it's h plus 3, then what it's going to do is it's actually, I guess it's kind of the opposite of what we see. But if we see something like h plus 3, then or h equals negative 3, I guess. So we see something like x plus 3, then that means that our vertical asymptote is going to be at x equals negative 3 because it moves 3 to the left. If we say something like x minus 2, then our vertical asymptote is going to be at 2. So it's kind of going to be that opposite sign, just like we see with a lot of functions. So with this in mind, let's go ahead and talk about how these functions shift, as well as deciding where their asymptotes are, their domain, and their range. So how does this one shift? Well, this a here, or this 3 here, it tells us that it is going to stretch, right? This plus 1 tells us we're going to the left 1. And this plus 2 tells us we go up 2. Now, how does this relate to our asymptotes, our domain, and our range? Remember, if it moves to the left 1, our left and right, or that h value, is actually going to be related to our vertical asymptote, or our horizontal asymptotes. Oh, yeah, vertical. Sorry, we're looking here. Our vertical asymptotes is related to h. So our vertical asymptote is then going to be at the opposite of this, or what happens when we go left 1, is going to be at negative 1. Our horizontal asymptote is going to be at positive 2. So positive 2 equals y, negative 1 equals x. And then what about our domain and range? Well, fun fact, our domain is always going to be all the real numbers minus whatever number our asymptotes are at. So with our domain, it's going to be all the real numbers minus the number -1. And so this is called set notation, where we say all the real numbers, so the set of any number minus the set of -1, which is the one number we're excluding. Our range is going to be the same way. It's all the real numbers other than the number 2, because that is where our horizontal asymptote is. What about this one here, our next one over? So what does this -6 do? Well, this causes it to stretch. It also causes it to reflect, right? So it's going to do both. So this function that we're looking at here is actually going to be like this. And then what do these other numbers do? Well, this -4, or this +4 tells us we're going to the left 4. And this -7 tells us we're going down 7. So how does that affect our asymptotes? Well, the vertical asymptote is going to be left 4 means x equals -4. Our horizontal asymptote is going to be where y is, so it goes down 7, so y equals -7, which means our domain is going to be all the real numbers other than the number -4. And our range is going to be all the real numbers other than the number -7. Awesome. Okay, so that is where we're at with those. Now we can use these functions to describe where it goes. Similarly, we can use these functions to then go the other way. What happens if we're given a graph of an equation that we then have to figure out what that equation is? So what we can do is, just like we did before, notice how all this information told us how much is stretched, our vertical and horizontal asymptotes, our domain, and our range. So let's talk about what the equation of this one might be. Well, it says that we have a vertical asymptote here at x equals -2. We have a horizontal asymptote here at y equals 3. So how do these affect it? Well, what that immediately does to our function is, if we have a vertical asymptote at x equals -2, we're going to have an x and then the opposite of -2, which is +2. And then we're going to have a +3 over here. Then the only thing we need to check to see is, did our function change at all? So other than those shifts there. And it looks like if we were to take our function here and move it back. So I'm going to move it back the way that it came. So we said that it went to the left 2, so I'm going to move it to the right 2. So where's our point that we're going to focus on? Let's focus on this point right here. So we're going to move it over 1, 2. And then it's going to, we went up 3, so we're going to bring it down 3. 1, 2, 3. And we can see that our center point here is at the point 1, 1, which is exactly where it is in that regular function. So we have a 1 on top. Look at that. So you can see how we can use that shift there of knowing where our vertical and horizontal asymptotes are to decide how it shifts. Let's take a look at one last example here. What about this one? So in this case, it doesn't list it, but right here, this blue dotted line is the line x equals -2. And our green dotted line here is the line y equals -1. So how does this affect our asymptote here? Well, what we can do is we can see that this point right here, where it crosses an actual dot, is at the point -1, 2. So if we move this one, remember that vertical asymptote says that we moved it to the left 2. So if I move it to the right 2, I'm back at 1. And if I move it down 1, we're back here at 1, 1. So we know that our number on top is going to be 1, because if we reverse our directions, we get back to that 1, 1 point, which is where our original function 1 over x exists, right? Because if I put 1 into 1 over x, I get the point 1 back out. So then what else do we know here? Well, our vertical asymptote tells us what goes on bottom. So it's going to be x. If it's a -2, we're going to have a +2. And this -1 tells us that it moved down 1. And this is our equation here. So before we go, what we're going to do is we're going to look at one last example here where we describe the transformations and then sketch the graph, state the asymptotes, and find the domain and range. So exactly what we've been doing. So here's our equation here. What does this tell us that we have? Well, this one tells us that it's going to look like the parent function that's shifted. What does this 2 tell us it does? This tells us we're going to go to the left 2. And this -3 tells us we are going to go down 3. So how would we then sketch a picture of it? Well, we know that our other one has the point 1, 1, and it kind of goes like this, and -1, -1, and it goes like this, right? If I put a -1 in, I get a -1 out. So we get something that looks kind of like this. So what we want to do is take that and shift it over. So I'm just going to shift it over. Now, if you have a graph, awesome, but I would recommend doing it without a graph, because that really describes to us what's happening here. So our original one looks like this. Now, what does our new one do? Well, our new one goes to the left 2. So if I were to trace along this line, what it's going to do is it's going to go to the left 2, 1. So here we are, 1, 2, and it's going to go down 3, 1, 2, 3. Okay, then similarly, we're going to have to trace this line and see what this line does. So it's going to go to the left 3, or left 2, 1, 2, and down, 1, 2, 3. And so this is where our new line is. Now, what is our new vertical and horizontal asymptotes? Well, we can find that from our equation itself. So our new vertical asymptote is going to be right at x equals -2, because remember, it comes from the opposite of this. This is going to tell us where our vertical asymptote is. What about our horizontal asymptote? Well, our horizontal asymptote is going to come straight from this element. So if we go down 3, that means y is going to be at -3 because it went down 3. And then our domain and range, remember, includes everything but those 2 values. So our domain is going to be all of the real numbers other than the number -2. And our range is going to be all of the real numbers other than the number -3. And that is how we can sketch a graph and kind of graph a basic rational function. If you have questions, feel free to ask, but please check out the next video in which we look at some functions that aren't written in this standard form here. We're going to end up looking at some functions that look like this and figure out how we can graph those. So please check out the next video in which we do that. If you have any questions, feel free to reach out.